Let's take a look at a kinetic friction problem based on the static friction problem we looked at before. So again, we have a mass of 10 kilograms, coefficient of static friction of 0.500, coefficient of kinetic friction of 0.350. We found in the previous problem that the force due to gravity was 98.1 newtons down. In this case, I'm going to call down negative. And since it was sitting on a desk, we found that the normal force was 98.1 newtons up, and I decided to call up positive. This time, I'm going to take an applied force of 50.0 newtons, and my question is going to be, what will the acceleration be? Now, I want to make a quick note here. In the previous problem, we found the maximum force of static friction. And that maximum force of static friction was less than this 50 newtons. Because of that, we know it's going to accelerate. If you're unsure of what's going on, please check out the other video. Since we know it's going to accelerate, we no longer care about static friction. This thing is going to be in motion, and once we're in motion, what we care about is kinetic. So we're going to go ahead and draw our free body diagram. In this case, the first thing I put up was the applied force, and I know that the frictional force will be opposite that applied force because the motion will be due to the applied force. The force due to gravity, as always, is going to point right towards the Earth. And again, because we're sitting on a desk, a horizontal surface, we know I have a normal force. I'm looking for the acceleration, and so I'm going to use my F net equation, always. In this case, you're going to notice my F net equation only contains the force of friction and the applied force. That's because earlier we already found our normal force and our force due to gravity, and we solved in the y direction already. Now we're only concerned with the x direction, so I'm only including these two forces. I also know I have the relationship that the net force is equal to the mass times the acceleration. A net force will cause a mass to accelerate. Relating the two, I have that ma equals the force of friction plus the applied force. Right now, this equation has two unknowns. I don't know my force of friction, and I don't know my acceleration. To solve this, we're first going to have to find the force of friction. Why don't I find the acceleration first? Simply because I can't. But because I have this relationship between the force of friction and the normal force, I can solve for the normal force. In this case, I have the force of kinetic friction is equal to the coefficient of kinetic friction times the normal force. So now solving for the force of friction, I'm just going to plug in my values. So I'm going to say the force of friction is equal to 0.350 times 98.1 newtons, which I'm going to find is 34.3 newtons. Now I know the magnitude of my force of friction. Remember, this is just a magnitude. This cannot tell me which direction it points. To determine which direction it points, I have to analyze the situation and see what would happen without friction. Without friction, it's very clear the applied force would cause the motion of the object to be towards the right. That means friction will oppose that motion and be towards the left. Going back to our net force equation, in which we found the net force is the force of friction plus the applied force, and again realizing that the net force can also be written as mass times acceleration, I can now plug in some values. I know my mass is 10 kilograms. Oh, I'm sorry. From the earlier problem, it was 10.0 kilograms. So I know my mass is 10.0 kilograms. I don't know my acceleration. But now I know my force of friction. And I'm going to decide to call left negative and right positive. So in this case, for my force of friction, I'm going to plug in a negative value of 34.3 newtons. For my applied force, because I called right positive, I'm going to plug in a positive value of 50.0 newtons. Now it's just simple algebra. The first thing I'm going to do is I'm going to combine the right side. And I'm going to get a value of 15.7 newtons on the right. On the left, I still have my 10 kilograms times my acceleration. 10.0 kilograms. The last step that I have to take is just dividing both sides by the mass. This is going to find an acceleration of 1.57 meters per second squared. This positive value is consistent with what we thought would happen. The positive value means it's towards the right. This makes sense because we know that it's the applied force that's resulting in this thing's motion, that is resulting in the acceleration. True, the net force is what causes the acceleration, and the net force is less because of this frictional force. But friction alone could not cause the motion. If you found that the object would be accelerating towards the left when it started at rest, that would mean objects just sitting on a table could fly in any direction they wanted due to a frictional force. Which, without the presence of a poltergeist, I think we all know isn't true.